Pluto, a far-off and jumbling world, was once considered a solitary legitimate planet, a member of our planetary family, regardless of the upsetting clarifications by leading astrophysicists Neil deGrasse Tyson and Michio Kaku. They brought Pluto back into the spotlight with shocking responsiveness, suggesting that this crisp world is on a potential stacked outline with Neptune. Yet how is it that this could work out? What might be the consequences of such a colossal event? Are we seeing an enamoring-influenced oddity, or is there something else to this oncoming, interminable mishap? Join us as we survey the normal consequences of a Pluto-Neptune influence. Pluto, a former planet that was confined to a more unpretentious individual planet, mostly in context of its enraptured orbit, remains a subject of interest in the vast cosmos. According to reliable figures from leading experts, Pluto's course is hazardously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku have both raised the alarm of a potentially hazardous debacle between these two planets, which could be an enormous danger to Earth. But how is such an event even conceivable? Pluto's orbit around the Sun is unlike any other planet in our closed planetary system. It requires a stunning 248 years to complete a single orbit. This suggests that, since its discovery in 1930, it hasn't even completed one round trip. However, the interest doesn't stop there. Pluto's way is described by its contorted shape, which deviates dramatically from the almost round orbits of the major planets. What makes Pluto's orbit even more puzzling is its inclination, hanging out there at 17 degrees to the ecliptic plane. The manner in which Pluto follows is stunningly more elliptical compared to other planets. This peculiar characteristic adds layers of complexity to its orbital model. Perhaps one of the most fascinating aspects of Pluto's orbit is its blending with Neptune's. For something like 20 years in each orbit, Pluto, in fact, draws closer to the Sun than Neptune, contrary to what we would expect based on their positions in the planetary system. This leads to the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of other planets. The evaluation of Pluto's orbit began not long after its discovery. At first, space scientists struggled to make heads or tails of its unique orbit. Unlike other planets, whose orbits lie close to the ecliptic plane, Pluto's orbit stood out with its extreme inclination and irregular shape. The mystery of Pluto's orbit crossing Neptune's lies in the stability of Pluto's orbit amidst these complexities. It is proof of the intricacies of celestial mechanics. The three-body problem in space is concerned with figuring out how three objects, like Pluto, Neptune, and the Sun, move and affect each other through gravity. It's like trying to predict where they will go based on where they start and how they pull on each other. In Pluto's case, this problem illustrates how its orbit, Neptune's orbit, and the Sun's gravity all interact in a complex manner. Terms like astrometric libration, scope, and the VSK wobbling contribute to this issue, according to astrophysicists. What's keeping all planets in their orbits is a kind of libration. In the case of Pluto and Neptune, this term means that whenever Pluto crosses Neptune's orbit, its position is always at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from influencing each other. Libration, on the other hand, suggests the gradual movement of a celestial body in its orbit. For Pluto, this means that when it comes nearest to Neptune or any other giant planet, it is positioned far above their orbital plane, contributing an extra layer of protection from potential collisions. Another key factor in this scenario is the VSK wobbling. This is named after three researchers, V.A. Apple, L.V., and K.U. Du, who studied how objects move in space. It's about how three space objects like Pluto, Neptune, and the Sun pull on each other with their gravity. This gravitational influence affects how they move. For Pluto, the VSK wobbling helps us understand why its path near the Sun is so unusual. Despite the apparent chaos, this influence has an effect to keep Pluto's orbit stable for an incredibly long period of time. The VSK wobbling shows that, even though things in space might seem wild and clashing, specific models and rules help keep everything in place. These factors help maintain Pluto's orbit, ensuring it doesn't crash into Neptune or stray off course. This three-body problem influences our understanding of how orbits change based on how space objects pull on each other, focusing on Pluto, our nearby planetary system, and distant stars. Furthermore, mathematical simulations in the late 1980s revealed that, despite these stable properties, Pluto's orbit is unpredictable. Minor deviations in initial conditions can lead to significant changes over long timescales. These peculiar properties of Pluto's orbit have been found to maintain consistency over exceptionally long periods of time. Recent computer models have helped us understand how the giant planets, like Neptune, Jupiter, and Saturn, influence Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This resonance helps keep Pluto's orbit stable. However, Neptune is not the only factor. Jupiter's gravity also plays a significant role in protecting Pluto's orbit, and Saturn contributes in that wide region as well. These tests show that Jupiter's gravity alone is powerful enough to ensure Pluto stays on a stable path for an incredibly long time, possibly even billions of years. Perhaps Neptune, Jupiter, and Saturn are working together to ensure Pluto can continue moving safely through space without running into trouble. These interactions are essential in the larger context of the universe, maintaining the balance and stability of celestial bodies. Without these factors, our solar system would be a place of much greater chaos and instability. Bodies like Pluto could easily collide with others or be flung out of their stable orbits, triggering a chain reaction among other celestial bodies. For Pluto, especially with the ongoing discussions about it possibly colliding with Neptune in the future, understanding its orbit is crucial. This gives us a clearer picture of the dynamic nature of our nearby planetary system. The case of Pluto illustrates how even the most seemingly unstable orbits can achieve a state of harmony. Understanding Pluto's orbit and its interactions with Neptune, along with the gravitational influences of Jupiter and Saturn, underscores a larger principle in astrophysics. The intricate dance of celestial bodies is not merely chaotic, but can exhibit patterns of stability over vast periods of time. These patterns, despite the seemingly unpredictable nature of the universe, reflect a deeper order governed by gravitational forces and the fundamental laws of motion. In fact, these insights into Pluto's orbit may also offer broader implications for how we think about the solar system structure as a whole. The ability of Pluto to maintain a stable orbit despite the unusual characteristics of its path, its eccentricity and inclination, provides crucial evidence for the resilience of orbital mechanics. It shows that, while the solar system might appear chaotic at first glance, there are forces at work that help maintain harmony and prevent catastrophic events, such as planetary collisions, which could otherwise destabilize the system. Pluto's ongoing existence, despite being relegated from its planetary status in the eyes of the scientific community, is a testament to the complexity and beauty of the universe. It raises questions about how we define planet and challenges us to reconsider our understanding of planetary behavior and the role of distant objects in our solar system. As technology advances, new discoveries will no doubt continue to shed light on these complex systems, offering a clearer understanding of how Pluto's path intertwines with those of the other planets. Moreover, as we continue to explore deeper into the far reaches of our solar system and beyond, it is likely that we will encounter more objects like Pluto, distant, eccentric, and somewhat mysterious, yet playing an essential role in the larger cosmic picture. These bodies may hold the key to understanding more than just the dynamics of our own solar system. They could reveal insights about the formation and evolution of planetary systems across the universe. The study of Pluto's orbit, therefore, is not just about one small celestial body. It's about understanding the forces that govern all planets, moons, and other objects within our solar system, and by extension, the forces that shape the dynamics of the universe itself. This knowledge could help us predict the behavior of distant exoplanets, unravel the mysteries of interstellar space, and even offer clues to the formation of new solar systems. In conclusion, while Pluto's position in the planetary hierarchy may be debated, its orbit provides invaluable lessons in celestial mechanics. The continued study of Pluto and its relationship with Neptune, as well as the role of other giant planets, will undoubtedly contribute to our broader understanding of the universe, reinforcing the notion that even the most seemingly unstable orbits can achieve a delicate balance, ensuring the stability of our solar system for millennia to come. Through the tangled cooperation of gravitational powers and orbital mechanics, it likewise shows the meaning of predictable information and the investigation of these idiosyncrasies to all the more readily sort out our spot in the universe. Examining the profundities of space frequently drives us to confront the whimsical idea of heavenly bodies. Also, Pluto's orbit is an ideal representation of this unusualness. The possibility of orbital resonation, which suggests the sensitive dependence of a celestial body's orbit on its initial conditions, is clearly outlined in the instance of Pluto. This suggests that even slight assortments in the little planet's position or speed can drastically alter its long orbit. Using mathematical simulations has been incredibly significant for understanding how Pluto moves in space. These simulations utilize complex math to model how Pluto, alongside other space objects like Neptune, pull on each other. By changing small nuances in the simulations, space specialists can see how even minute changes can have an enormous impact on where Pluto ends up. In the late 1980s, these simulations uncovered something truly intriguing about Pluto's orbit. Despite having systems like asteroidal libration and degree libration to keep it stable, its orbit can still be fiercely unpredictable. If you start with even a minute difference in where Pluto is, or how fast it's moving over various years, its path could end up looking completely different. Nevertheless, this chaotic Pluto orbit remains stable for billions of years. This suggests that Pluto's journey around the Sun has a certain order to it, despite seeming erratic at first, particularly when it involves erratic orbits like Pluto's. This presents enormous challenges. The inherent nature of these systems suggests that long-term predictions are often fraught with uncertainties. While mathematical simulations provide an excellent resource for understanding and predicting the future behavior of celestial bodies, they also highlight the limits of our expectations. These models rely heavily upon the accuracy of initial conditions and the complexity of the interactions they simulate. Any slight error or deviation can drastically change results, making accurate predictions a daunting task. Furthermore, the chaotic nature of large orbits like Pluto's serves as a reminder of the constantly evolving and dynamic nature of the universe. While we have made great strides in understanding space, the representation of Pluto reminds us how our understanding of the universe is still limited. Understanding the gravitational effects of the giant planets on Pluto's orbit offers critical insights into the broader dynamics of the nearby planetary system. It shows how the presence and position of each planet can have sweeping implications for the stability and trajectory of various bodies within the system. So why are some astrophysicists suddenly raising concerns about a potential collision between Pluto and Neptune, despite all these complex forces trying to prevent such an event from occurring? Neil deGrasse Tyson, a renowned astrophysicist, offers a book-length perspective on the mysteries of our nearby solar system, particularly the enigmatic representation of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, provides a brilliant analysis of the evolving nature of celestial mechanics and the public's fascination with the overlooked corners of space. What is happening? Pluto's renaming is framed within the ever-growing understanding of our nearby planetary system. He views the renaming not as a diminishment, but rather as a crucial shift in our growing understanding of the many bodies surrounding our Sun. Tyson's approach to celestial mechanics is one of constant learning and change. He sees the intricacies of Pluto's orbit, as well as its interactions with Neptune, from a perspective that acknowledges the ever-changing nature of space. He suggests that while Pluto's orbit is stable for now, it could undergo significant changes in the future. This possibility serves as a reminder of how much we still have to discover about the forces shaping our solar system. While Tyson acknowledges the current stability of Pluto's orbit, he emphasizes the importance of continuing to observe and model its trajectory. As space exploration advances, the intricacies of these distant planetary bodies become more accessible. Tyson and other astrophysicists stress that our understanding depends on refining our models, using increasingly sophisticated simulations, and integrating new data collected from ongoing missions, such as NASA's New Horizons spacecraft, which recently provided us with a wealth of information about Pluto's surface and atmosphere. What makes Pluto's future especially intriguing is the potential for new discoveries about its relationship with Neptune and other celestial bodies. The idea that Pluto could eventually, in the distant future, change its path and collide with Neptune is one that seems unlikely in the short term. However, the celestial dance between these two worlds and the forces that shape their interactions illustrates the kind of unpredictability that makes astronomy such a dynamic and exciting field of study. Astrophysicists, including Tyson, are not suggesting that an inevitable collision between Pluto and Neptune is likely, but instead that the possibility, however remote, highlights the capricious nature of the universe. These possibilities remind us of the delicate balance that governs the motion of celestial bodies. The continued study of Pluto, its orbit, and its relationship with Neptune enhances our understanding of the forces at play within our solar system and underscores the importance of ongoing research. For now, Pluto's future remains uncertain, but the lessons we gain from studying its orbit and its fragile interactions with other planets can have significant implications. They not only allow us to better understand the distant worlds in our solar system, but also provide insights that could one day aid in the understanding of other planetary systems. Just as we have learned from the past, continuing to observe and analyze these distant worlds can provide answers to questions we haven't even thought to ask yet. As humanity ventures farther into space, exploring the outer reaches of our solar system and beyond, Pluto will undoubtedly remain an object of profound interest. Its journey, though seemingly isolated and stable, serves as a reminder of the intricacies of orbital mechanics and the potential for hidden surprises in the universe. Whether a Pluto-Neptune impact ever happens or not, the study of Pluto will continue to push the boundaries of our knowledge and inspire future generations of scientists, astronomers, and explorers to learn more about the mysteries of our universe. By understanding Pluto's orbit and its interactions with Neptune, we not only gain a deeper appreciation for the delicate balance of our solar system, but also engage in the ever-expanding quest for knowledge about the vast and mysterious realms of space. This is a reminder that even the most distant objects in our sky, like Pluto, play a fundamental role in the grand puzzle of the universe, one that we are only just beginning to fully appreciate. The study of Pluto's orbit and its interactions with other celestial bodies, particularly Neptune, is just one example of how small, seemingly insignificant details can have large, far-reaching consequences. By examining Pluto's unique position within our solar system, we gain a better understanding of how the forces that govern motion in space shape the evolution of planetary systems. The gravitational pull of the giant planets, the delicate dance of orbits, and the unpredictable nature of these systems all contribute to the dynamic, ever-changing nature of the universe. As our technology advances and we continue to gather more data from missions like NASA's New Horizons, our understanding of Pluto and its place in the solar system will only grow. New insights into Pluto's surface, atmosphere, and its interactions with its environment provide valuable information not only about Pluto itself, but also about the broader processes that govern planetary systems. As scientists and researchers delve deeper into the mysteries of our solar system, we may uncover even more surprising and unexpected facts about this distant dwarf planet. Beyond Pluto, the lessons learned from studying its orbit and its interactions with Neptune could have broader implications for understanding other planetary systems in our galaxy. The dynamics that govern the movement of celestial bodies are universal, and by studying these systems, we can better understand the forces at play in other star systems. Whether it's the gravitational effects of a massive gas giant on a nearby rocky planet or the delicate balance between multiple bodies in a distant system, the principles that we observe in our own solar system apply on a much larger scale. In many ways, the study of Pluto is emblematic of our broader quest for knowledge about the universe. It serves as a reminder of the beauty and complexity of space, the ever-evolving nature of scientific discovery, and the endless possibilities for new insights and breakthroughs. As we continue to push the boundaries of space exploration and technology, the mysteries of Pluto, Neptune, and the entire solar system will continue to inspire curiosity and wonder. As we look to the future, we can only imagine what new discoveries await us in the far reaches of our solar system and beyond. Whether we uncover new details about the distant worlds within our own system or venture out to explore the stars and planets of other systems, the pursuit of knowledge will continue to drive us forward. Pluto, with its quirky orbit and uncertain future, will remain an intriguing subject for study, offering both answers and new questions as we strive to uncover the secrets of the universe. Ultimately, it is through our ongoing exploration and study of these distant bodies that we will continue to expand our understanding of the cosmos and our place within it.